right? Continuing with chapter 1 and sections 1.1 and 1.2, continuing where we left off from the previous video. We were talking about the scientific method and the different subheadings under the scientific method. And once you do have your hypothesis that was proven conclusively by your data, then of course you have to, as I explained before, publish it and leave it open for scrutiny so that others might be able to mimic your experiments and come to the same conclusions as you did. Okay, so in this study check problem, identify each of the following as an observation, a hypothesis, an experiment, or a conclusion. So A is, during your visit to the gym, your trainer records that you ran for 25 minutes on the treadmill. So this is an observation because on your visit he observed that you were running for 25 minutes on the treadmill. Okay. Next, B, scientific studies show that exercising lowers blood pressure. So a study was conducted presumably with a group of people, and in that study group it showed that their exercising ended up lowering blood pressure. So that was a conclusion, a result that was drawn from this study. All right. Your doctor thinks that your weight loss is due to increased exercise. Now, weight loss is dependent on a lot of factors. It could be exercise, of course, but diet changes and so on, lifestyle changes. So when the doctor presumes that it was just exercise that led to weight loss, he's making a hypothesis, which he would then have to prove conclusively that it was just exercise that led to your weight loss. Okay, so that's a hypothesis. A good definition of chemistry is the science that seeks to understand what matter does by studying what atoms and molecules do. This is a valid definition of chemistry. The science that seeks to understand what living organisms do by studying the molecules that make up the organism. Now, chemistry doesn't confine itself to just studying living organisms. It studies chemicals that make up both living and non-living entities. So therefore would be an incorrect definition. Science that seeks to understand what the universe does by studying interactions of molecules with atom. Now, chemistry is not just confined to studying interactions of molecules with atoms. Atom interactions are studied, atom to molecule interactions, molecule to molecule interactions are also studied. So this is inaccurate for the definition of chemistry. The science that seeks to understand the interactions of molecules for the sake of advancing human control over nature. Chemistry is not just confined to only looking at advancing human control over nature, all right? Most times when scientists study something, it's out of curiosity. They observe something and then they go about studying it, formulating their hypothesis, collecting data to support their hypothesis, and so on, all right? So this is also not a good definition for chemistry, and therefore A seems to be the only answer that fits well as a proposed definition for chemistry. Which statement about the scientific method is true? The scientific method emphasizes reason as the way to understand the world. Now, this is more a classical way with the Greek philosophers and thinkers using just reason and analysis to understand things and not really conducting experiments and collecting data and facts to support their reason or their thinking. All right. Now, the scientific method prides itself on collecting finite data and facts to support um, their contentions. All right. So the scientific method emphasizes observation and reason as the way to understand the world. This observation, yes, but just confining themselves to observation and reason would be inaccurate. The scientific method emphasizes observation and experimentation as the way to understand the world. This would be the best choice because observation leads to formulating a hypothesis, and then the experimentation leads to proving or disproving that hypothesis. Scientific method emphasizes scientific laws as the way to understand the world. The scientific method is basically to gather data to support or disprove your hypothesis, and then if your hypothesis is supported by your data, then it can lead to the formation of a theory, and eventually, if it stands the test of time, it can become a scientific law, all right, or a statement of fact. But it automatically doesn't look at just determining scientific law, all right? So this would be inaccurate. So C would be the best answer as a true statement for scientific method. Which of the statements below is not part of the scientific method? Observation and measurement, formation of a hypothesis, testing of a hypothesis, refinement of a hypothesis. All of the above are part of the scientific method, and E is the correct answer. They're all part of the scientific method. Which statement accurately describes the purpose of experiments? Experiments are designed to produce the results predicted by a theory. No, because you don't know how your experiments are going to turn out, all right? You hope that your experiments do support your hypothesis, but in case they don't, then you have to revise your hypothesis and then conduct a new set of experiments. Experiments can be replaced by a simple logical reasoning of known facts. Now, if it is scientific method that you're using to gather facts, then reasoning alone will not be adequate. You have to be able to have data to back your facts that you've gathered, all right? Experiments are designed to produce unexplainable results for further investigation. No, when you are designing experiments, you're trying to find results that will support your hypothesis. If they end up producing unexplainable results, that means you'll have to go back to the drawing board and then see how you can explain those unpredicted results, all right? So you'll have to revise your hypothesis and come up with a fresh set of experiments. Experiments look for other observable predictions of a theory. And yes, this would be more accurate. Once you have conducted a set of experiments and you can see a pattern developing, you can draw other predictions from that set of experiments, and then you can go about testing out your other predictions as well. Okay, so D would be the best answer. Which of the following is considered a hypothesis as opposed to an observation? Spiders have 8 legs. That's an observation. Birds can fly is an observation because they have hollow bones. So you're giving an explanation, a possible reason for why birds can fly. So that would be formulating a hypothesis. Fresh lava from a volcano is hot. That's an observation. The Washington Monument is 555 feet tall. That's again an observation. So birds can fly because they have hollow bones is a hypothesis. Which of the following is an example of an observation? All matter is composed of small, indestructible particles called atoms. This is almost like you're giving an explanation for or a statement of what you think matter is made up of, all right? So it's definitely not an observation. Reactions occur due to the transfer of electrons. Again, you're explaining why reactions occur, so that's not an observation. When a can of soda pop is opened, a fizzing sound is heard. Now this is an observation because you hear that fizzing sound every time you open a can of soda. Okay, you're not explaining why the fizzing occurs, simply stating what you have observed. Flammable objects contain phlogiston. Again, you're trying to explain why some objects are flammable, all right? So that's not an observation. So C is the best answer. All right, so that's the end of sections 1.1 and 1.2. These are some of the questions I'd like you to work on in addition to your other homework problems, etc., from the supplement and mastering chemistry. So at a minimum, work on these problems found on page 6 of your textbook. They are 1.7, 1.8, 1.9, and 1.10. All right, the next video will continue on with sections 1.3.